Hello everyone, welcome to Chem.EduAcademy. So today we will start a new course on stereochemistry of organic compounds. This is an important topic for our HSST chemistry. So we will start with the basic concepts of stereochemistry. Okay. So with this basic concept, I mean that we all know that most of the organic compounds are in three-dimensional structure. That means if you are taking an structure of organic compound, some bonds are above the plane, some of them are below the plane, some of them is on the plane, likewise. So most of the structures are three-dimensional, but we have to convert that three-dimensional structure of organic compounds to a two-dimensional structure so that we can draw it in a plane or paper, isn't it? But നമ്മളിപ്പോൾ ഈ three-dimensional structure two-dimensional structure ആക്കി convert ചെയ്യുന്ന സമയത്ത് we should represent that bonds in organic compounds same as that of three-dimensional structure, isn't it? So for that we use some representations in order to convert this three-dimensional structure to two-dimensional structure. So today in this video we will study the representations of that three-dimensional structure in two-dimensional figures. Okay. So we have different types of representations, and the first one is that tetrahedral representation. What is tetrahedral that you know? Tetrahedral structure. Tetrahedral means in case of methane molecule, we know that structure of methane is tetrahedral, isn't it? So this is the shape of the such molecules. I will draw it here. This is a structure, isn't it? This is actually the tetrahedral structure, and three bonds are towards us and one of the bond is behind that figure, isn't it? So here you can see one dotted bond, and this dotted structure represent that that bond is away from our eyes. That bond is away from our eyes. So we convert that three-dimensional structure, three-dimensional tetrahedral structure to two-dimensional structure. Okay, how that bond that is behind the figure is just represented as dotted line. So നിങ്ങൾ എവിടെ ഇങ്ങനെ ഒരു സ്ട്രക്ചർ കാണുമ്പോഴും ഒരു ഡോട്ടഡ് ലൈൻ റെപ്രസെന്റ് ചെയ്തിട്ടുണ്ടെങ്കിൽ യു ഷുഡ് റിമൈൻഡ് ദാറ്റ് ദാറ്റ് ബോണ്ട് ഈസ് ബിഹൈൻഡ് or away from us. Okay, so this is the first or oldest representation, and the second one is that so this is the second type of representation, that is flying wedge formula. Flying wedge formula. So here I have taken one example. In this figure you can see one dark line, one dotted line, and other two bonds are straight lines. Okay, and this dark line indicates, dark bond indicates that this bond is above the plane, above the plane. If you are considering this as a plane, this bond or this OH group will be above the plane, and this dotted line indicates or slash line indicates that this COH group will be in the below the plane, below the plane. Okay, that will be below the plane, and the straight line indicates that these bonds are on the plane, on the plane. So likewise we can represent a three-dimensional figure in two-dimensional plane. by converting each bond or by representing each bond according to this flying wedge formula. Clear? I will explain it once more. If you are given one example like this, in that you can see one dark line, one dotted line, and straight bond. Dark line indicates that bond is above the plane, and dotted line indicates that group is below the plane, and others are on the plane. Clear? So this is the second type of representation. So this is the third type of formula, that is representation, that is zigzag formula. In this is somewhat similar to flying wedge formula, but one difference is that here you can see the central carbon and 3 other bonds, and we have one more bond that is towards the hydrogen, that is not represented here. So in zigzag formula we won't represent the hydrogen. Okay, others are same. This dark line indicates that bond is above the plane, and this dotted line indicates that bond is below the plane, and straight bond indicates that is on the plane, and we have one more bond that is towards the hydrogen, that is not represented in zigzag formula. So the main difference between this zigzag formula and flying wedge formula is that in zigzag formula we won't represent the hydrogen bond. Okay, we won't represent the hydrogen in that structure. Clear? So we have 3 more representation that we will discuss in our next section. So that's all for this video. I hope all like this video. Thank you for watching, and if you like this video, please subscribe my channel, and you can share this video with your friends, and see you in next video. Have a nice day. Bye.